A soft drink company produces soft drinks in cans, whose volume reads 355 milliliters. Every 30 minutes, 5 cans are taken from the production line. The volume in each of these cans is measured and recorded. Some of the results are noted in the table below. Now we look at the table. We have 10 o'clock. Here are the 5 cans that were measured at 10 o'clock. Then we have 10:30. Here are the 5 cans at 10:30. 11. So we have the 5 cans for 11. And then our 11:30 measurement time. And here are our 5 cans for 11:30. Question number 1 says, enter the data into L1 into your calculator and calculate the mean and standard deviation around your answers to 2 decimal places. So what it's looking at is it's looking at all of this information right here. You're going to put it all into L1. You can either go downwards as you put it in, or you can go across. So this number, then this number, then this number, then this number, then this number, all into your L1. So it doesn't matter which way you go, enter your data, whether you're going downwards or whether you're going across, so long as you have all 20 pieces of information in your L1. At this point then, I want you to calculate your mean and standard deviation. So pause the video, enter the table, calculate your mean and standard deviation, and then come back and check your answer. So, when you calculated your mean and your standard deviation, you should have ended up with a mean of 353.99. If you didn't, go back and check to make sure that all of your numbers are correct and that you didn't accidentally enter one of them incorrectly. It is really easy when you have a big list of numbers to accidentally hit the wrong button on your calculator. And your standard deviation, we have 1.49529 in the calculator. It says to 2 decimal places, so 1, 2, so this is where we want to round to. 5 says that the 9 needs to go up, and when it goes up, 9 plus 1 is 10, which means we're going to end up with 1.50. You do need the 0. If you don't put the 0 in, you've only rounded it to 1 decimal place, not 2 decimal places. Now, using this information, it says assume that the data is normally distributed, label the curve with the average and the standard deviations rounded to the nearest hundredth. Hundredth is 2 decimal places, so we are okay with that. So there is our bell curve, and we know that our mean goes right in the middle, so this will be 353.99. We know that our standard deviation was 1.50. Now, as we go to look at the question, remember when we go this way, we add a standard deviation. When we go this way, we subtract. So if we look at the next line, this line right here would be 353.99 plus 1.50. And when we do that, we get 355.49. Okay, so 355.49. When we add 1.5 to this to get our next spot, we're going to end up with 356.99. And then this one, when we add 1.5 to this, we will get 358.49. So now we've done the adding 1 standard deviation to get our 3 that are going up. In the other direction, we're looking at subtracting our standard deviation. So for our first line here, this one here would be 353.99 minus 1.50, which gets us 352.49. To get our next spot, we're going to take this number, subtract 1.5 from it. When we do that, we get 350.99. And then for our last one, we're taking this, subtracting 1.5 from it, and we get 349.49. As we go to use this, let's put in the percentages into our bell curve that we have looked at already within this lesson. This is one standard deviation from here to here, which was our 68%. So that made this 34%, and this was 34%. Our next ones out were 13.5% and 13.5%. We then have 2.35% on each of them. And then our last tiny sections were 0.15% each. Okay. That is going to help us as we go through and answer our next questions. So, question number 3 says, find the percentage of cans with the volume A is less than 352.49 milliliters. Here's our 352.49. It was less than that. So we want to go, less is where the values are getting smaller. So if we look at our 352.49, this is bigger, this is smaller, so less is going to be that direction. So we're going to want to add up these 3 sections to get the answer. So as we do that, we have 0.15% plus 2.35% plus 13.5%, which gives us a total of 16%. So 16% of the cans have a volume less than 352.49 milliliters. Our next example, so B says, greater than 356.99. Well, if we look at our curve, there's our 356.99. Greater than would be bigger. So if we look at both sides, this is smaller, this is bigger. So that means as we take a look at it, we want to go in this direction. So for B, we are going to add these 2 values together. So we're adding 2.35% plus 0.15%. And when we do that, we get 2.50%. So what this is saying is that 2.5% of the cans have a volume bigger than 356.99. C asks us to determine the volume between 350.99 and 355.49. So let's find the 350.99 and the 355.49 on our bell curve. When we go to do that, here's our 350.99. Here is our 355.49. And so we're looking at the volume between them. So that means all 3 of these sections will need to be added together. And as we go to do that, we get 13.5% plus 34% plus 34% for a total of 81.5%. The last question on this example has us estimating the range of volumes for the 55 milliliter cans of pop. Well, we need to know what the smallest can is and what the biggest can is. So going back to our table, we're going to go through all of our data information up here, looking for our smallest can and for our biggest can. And as we search through, there's our smallest can, and there is our largest volume in the can. And remember that the range is the biggest minus the smallest. So as we go to do this, we're going to take the 356.2 minus 351.0, and we get a range of 5.2 milliliters. So there's really only 5.2 milliliter difference between the biggest can and the smallest can.